All right, so this is section 2.5, exercise 10. So we've seen these two piecewise linear functions in some other exercises. Now we're going to be using it to deal with the chain rule. So we have this function c, which combines or composes p with q, and I want to find a couple of derivatives here. So first, what is c prime of 0? So first, let's figure out what c prime of x is in general. So to apply the chain rule here, c prime will be equal to p prime of q of x times q prime of x. So specifically, c prime of 0 is equal to p prime of q of 0 times q prime of 0. So we need a couple things first. We need to look at the function q, which is green. What is q of 0? So let's make some notes up here. Q of 0 is equal to what? Q is green, so q of 0 is 2. And what is q prime of 0? Q prime of 0 is equal to, so we have a horizontal segment there, so that'll be 0. So I think because of that, I can simply say that this is going to be 0. Because if q prime of 0 is 0, I'm going to multiply by 0. That's going to have to be 0. So what about c prime of 3? C prime of 3 is equal to p prime of q of 3 times q prime of 3. So what are q of 3 and q prime of 3? Q of 3 is equal to 0. Q prime of 3 is equal to, looks like, -1. So I said that c prime of 0 was equal to 0. What about c prime of 3? Well, not quite, because I don't really want, it doesn't really matter what q of 3 is. That's kind of a means to an end. Q of 3 is 0, but what that really means is I'm going to find my derivative this way. E prime of 0 times q prime of 3. So I need to find out what is p prime of 0. So p is which function? The blue. So p prime of 0 will be this slope here, which looks to be positive 1/2. So this will be 1/2 times q prime of 3, which is -1. So final result here is -1/2. All right, moving on to the next part. Find a value of x for which c prime of x does not exist. Okay, so I think there'll be a few, but let's just try to figure out at least one. So let's remind ourselves what c prime of x is. We said it was equal to p prime of q of x times q prime of x. So why would this not exist? Basically, this derivative would not exist if the derivative of q does not exist, or the derivative of p does not exist for some value of q of x. So where is q? Q is not differentiable at what points? At x equals what? I believe that's going to be -1 and 1. So if we look at the q, which is the green function, we have hard corners at x equals -1 and x equals 1. So those are 2 points where this derivative would not exist. So we've already answered the question, but let's see if we can be complete about this. Where else would this derivative not exist? So where would p prime of q of x not exist? Well, to answer that question, let's talk about where is p prime not differentiable. I believe that's also at -1 and 1. So we kind of got to look at this in steps here. What's going to cause us to try to differentiate or take the derivative of p at -1 or 1? Well, that's going to come from where is q of x equal to -1? Or where is q of x equal to +1? So if we say y is equal to -1, then where does q, the green function, equal -1. It looks like that's a value of x equals -2 and only there. What about where x equals 1 or y equals 1? I apologize. Where does the green function equal 1? So I see two different places. One is x equals 2, and the other one is a little bit harder to pin down, but I believe that's going to be somewhere between -1 and -1.5. Let's go ahead and estimate, and we'll say that's -1 1/3 or -4/3. So I believe I have 5 different values where this derivative c prime would not exist. -1 and 1 because that's where q is not differentiable. Also, I need to say something here. It's not where q prime and p prime are not differentiable, just where q and p are not differentiable. And we also have these points x equals -2 and x equals 2 and -4/3. All right, now we have two more functions, y and z. So let's handle those one at a time. So we're told that y of x equals q of x. So something we rarely do, but it's totally acceptable to compose a function with itself. That's fine. So what is y prime of x? Y prime of x is equal to q prime of q of x times q prime of x. And we care about where this is, or what the value of this derivative is at x equals -2. So q prime of q of -2 times q prime of -2. So let's make some notes here. What is q prime of -2? So q is the green function, and it looks like the slope here looks like +3. What is q of, we also need to know what q of -2 is. At x equals -2, the y value is -1. So are we done? Not quite, because since q of -2 equals -1, let's just take some steps here. That means I need to find this q prime of -1 times q prime of -2. So basically, I replaced q of -2 with -1. So now I need to find what the derivative of this function is at -1. And I think we're stuck because we said the q is not differentiable at -1, which means since the derivative, there are many derivatives I had to consider to find y prime of -2. But if one of them fails to exist, then that means the overall derivative fails to exist. So y is not differentiable at x equals -2. So let's move on to z prime of 0. So this is q of p of x. So z prime of x is equal to what? Q prime of p of x times p prime of x. And we want to evaluate that at a specific value of x. So q prime of p of 0 times p prime of 0. So what is p prime of 0? P is the blue function. So p prime of 0 will be this slope here. Looks like that's a half. What is p of 0? That looks like it's -1/2. So let's, again, like kind of just do this layer by layer. So I'm going to replace p of 0 with -1/2. So what's q prime of a half times p prime of 0? Now we're going to find q prime of -1/2. So when x equals -1/2, this vertical dashed line here, what is the derivative of q, the green? That'll be 0. So here I get 0 times p prime of 0, which is a half. That derivative is equal to 0.